the root locus diagram of a system using the rules for the root locus technique. So let's see what is our problem. So our problem is to sketch the root locus of a unity feedback system with open loop transfer function given to us as GSHS equals to K upon S plus 2, S plus 3, as the value of K is varied from 0 to infinity. So let us sketch or plot the root locus of this system. We will follow the rules or the steps of the root locus technique one by one to plot this root locus. The first step is to determine all the poles and zeros of this system. So as you see that the poles, they are obtained by equating this denominator term to 0. So S plus 2, S plus 3 equals to 0. So we have the roots of this equation as S equals to 0, S equals to minus 2 and S equals to minus 3 at K equals to 0. Okay, how we are getting the roots? We are putting it into the equation 1 plus GSHS, that is the characteristic equation. We are putting the value of GSHS here, K upon S plus 2, S plus 3 equals to 0. Then we are getting the equation as S plus 2, S plus 3 plus K equals to 0. This is our characteristic equation of this system. Now here we are taking the value K equals to 0. So if K is equals to 0, this remaining term will be equal to 0. So this is here. Now take the values, take out the values, roots of this equation. We are getting 3 roots. S equals to 0, S equals to minus 2 and S equals to minus 3. So these 3 values, they are the poles of this system. Okay, and 0, because here we are not having any 0. So these poles, the root locus, we are having no 0 for this system. Okay, so in the first step we have obtained the open loop poles and zeros of this system. Now second step is the starting and the ending point of the root locus. Starting the root locus, they starts from the poles and they terminates at the zeros. Here we are having 3 poles. S equals to 0, S equals to minus 2 and S equals to minus 3. And zeros, we are not having any 0. So the root locus, it will start from the pole but it will terminate here at infinity. Okay, that is K equals to infinity. It will start from K equals to 0 and it will terminate at K equals to infinity. So this is the starting and the ending point of the root locus. Now step 3. In step 3, we will determine the direction of the root locus branches. Here we are having P greater than Z. That is, the number of poles is greater than 0. Poles are 3 and 3 is greater than 0. So the number of branches will be that equals to number of poles, that is, there will be 3 branches. Okay, 3 branches of root locus. Now plot these roots or the poles of the system on the S plane. This is our imaginary axis. This is real axis. Okay, this is 0, S equals to 0. Then we have -1, -2, -3, -4. Okay. Now S equals to 0 is a pole, S equals to -2 is a pole, and S equals to -3 is a pole. So we are having 3 poles. Now to determine the direction of the root locus branches, take 3 points. Take point across all these 3 poles. Suppose this is P1, and for this pole, there are 2 points P2 of about this second pole, and there are 2 points across this pole also. So if we start from here, from this point, then calculate the number of poles and zeros on the right hand side of this point. We have 1, 2, 3. 3 poles on the right hand side of this point. So the direction of the root locus for this pole, S equals to -3, it will be towards this point. Okay. Okay, so it will be in this direction. Now for this point P3, the number of poles and zeros on the right hand side is 1, 2. That is even. So the direction of root locus for this pole S equals to -3, it will not be in this direction, that is towards this point. Now for check for this pole S equals to -2. For S equals to -2, we have taken 2 points. First check for this point. For this point, we are having the number of poles as 2 on the right hand side. So the direction of root loci will not be towards this point. Now for this P2 point, the number of poles is 1 on the on the right hand side. So the direction of root loci will be towards this point. Okay. Now for P1, the number of poles is 1 on the right hand side. It is odd. So the direction of root loci will be towards this point. Okay. And for this point, the number of root loci is the number of poles is 0 on the right hand side. So it will not be in this direction. So this is the root locus branches for these 3 poles. We have known that this is existing between these 2 parts. Okay. So this completes our step number 3. Now step number 4. As you can see in this plot of the roots, that this for these two poles are adjacent to each other, and these root locus branches, they are coinciding with each other, they are meeting at a point. So this point where these two root loci branches are meeting, it is called the breakaway point. So let us calculate this breakaway point. Now breakaway point, so the breakaway point is calculated by differentiating the open loop transfer function with respect to S and then equating this differentiation value to 0. So our GS is given to us as K upon S, S plus 2, S plus 3. In the question, we are given GS HS equals to K upon S, S plus 2, S plus 3. So HS is 1 because it is a unity feedback system. So GS is equal to K upon S, S plus 2, S plus 3. Now differentiate this with respect to S. We can there are two methods to find out this differentiation. First is to apply the differentiation formula, and second method is to directly find the breakaway point by letting this S as x, 1 upon x, 1 upon x plus 2 and 1 upon x plus 3 equals to 0. So we are having x plus 2, x plus 3 plus x plus 3 plus x plus 2 equals to 0. Solve this, we are having x square plus 5x plus 6 plus x square plus 3x plus x square plus 2x equals to 0. So we are having 3x square plus 10x plus 6 equals to 0. If we solve this equation, we will get the value of x as minus 0.784 and x equals to minus 2.549. So this is one method or the direct method to find the value of the x or the value of the breakaway points. Another method is to differentiate it, apply the differentiation formulas. Differentiation of this will be k will be 0, so it will become 0, and the differentiation of this denominator equation is 3s square plus 10s plus 6 divided by s plus 2 s plus 3 whole square. Okay, so this is the differentiation of this open loop transfer function. Now put it to equate it to 0. So we will get 3s square plus 10s plus 6 upon s plus 2 s plus 3 equals to 0. We will be getting 3s square plus 10s plus 6 equals to 0, because when this term goes to the right hand side, it will be multiplied with 0, so it will become 0. The roots of this equation or the solution of this will be s equals to minus 0.784 and s equals to minus 2.549. Okay, so these are the two values of the breakaway points. We can use any of the two methods to find out the breakaway points. Either we can apply the direct differentiation formulas or we can use this factorization method. Now, out of these two values, that is s equals to minus 0.784 and s equals to minus 2.549. Now if we see our root locus diagram which we have plotted here, so the breakaway point will be somewhere between s equals to 0 and s equals to minus 2, and we are getting the values as s equals to minus 0.784 and minus 2.549. So this point is invalid because it is not lying between this s equals to 0 and s equals to minus 2 point. It is minus 2.549, so it is somewhat here. So our valid breakaway point is s equals to minus 0.784. This is invalid because it is not lying between s equals to minus 2 and s equals to 0. So this is not a breakaway point. Now our next step is step number 5. Now we will determine the asymptotes on the real axis. Okay. So for asymptotes, we have to first determine the intersection point of the asymptotes with the real axis. So intersection point, its formula is x equals to summation of p minus summation of z upon p minus z. So poles we are having s equals to 0, s equals to minus 2 and s equals to minus 3. So summation of p will be 0, minus 2, minus 3, that is minus 5. And zeros, because we are not having any 0, so it will be, its summation will be 0. So it is minus 5, minus 0. Number of poles are 3, so p equals to 3, and number of zeros is 0, so it is 0. So we are getting here the value as minus 5 by 3, or x is equals to minus 1.667. So it is the intersection point of the asymptotes with the real axis. Now in second part we will find out the angle of the asymptote. How we can find out the angle? We have a formula for it. Theta equals to 2m plus 1 into 180 degree and divided by p minus z. So it is the formula for the angle of asymptotes. Here m will be equals to 0, 1, 2 till we are having p minus z minus 1. So p we are having 3 poles and zeros is 0 and then minus 1. So 3 minus 1, 2. So the value of m will be 0, 1 and 2. Okay. Put the value of m here. Theta is equals to 2. First putting m equals to 0. So 2 into 0 plus 1 into 180 upon p minus z. Number of poles is 3 and number of zeros is 0. So theta will be 0 plus 1 into 180, 180 by 3. So it will be 60 degrees for m equals to 0. For m equals to 1, put 2 into 1 plus 1, that is 3 into 180 upon 3. So theta will be 180 degrees. For m equals to 2, put here 2 2s are 4, 4 plus 1, 5, 5 into 180 by 3. Okay, so here we are getting the value as 300. So for m equals to 0, theta is 60 degree. For m equals to 1, theta is 180 degree. For m equals to 2, theta is 300 degrees. So we have obtained the three angle of the asymptotes for the three branches which we are getting in the root locus. Now our next step is, that is step number 6. Now in step number 6, we will determine the intersection of the asymptotes or the branches of the root locus with the imaginary axis. Intersection of root locus branches with imaginary axis. We were having two methods to find out this. First was to put s equals to j omega in the characteristic equation, and second was to use the root stability criteria. So here we will use the root stability criteria to find the intersection point. The characteristic equation of this system was s cube plus 5s square plus 6s plus k equals to 0. Okay, characteristic equation we have already obtained in the first step. So use this characteristic equation, form the root array s cube, s square, s1, s0. Coefficient of s cube is 1, then 6, here 5 and k. So it will be 30 minus 5 6 are 30 minus k upon 5, it will be 0. Then 30 minus k into this, and 5 into 0 is 0. So here we will get k. So this is the root stability criteria. We have formed the root array. Now for the system to be stable, so in a root stability criteria, the system is stable when in the first column there is no sign change. That is, here we are having positive, so all the coefficients, they should be positive, that is greater than 0. So 30 minus k upon 5 should be greater than 0, and k should be greater than 0. Okay. So from here we are getting the value as 30 minus k greater than 0. So k should be equals to greater than 0, or it should be equals to 0. So 30 minus k, it should be 0. That is k equals to 30. Okay. So we have obtained the value of k, that is our gain. And this is the intersection of the root locus branches with the imaginary axis. Now for this k equals to 30, we are going to determine the value of the omega s value. Okay, gain we have obtained. Write the substitutory equation, use the row just above this and equate it to 0. So 5s square plus k equals to 0. So it will be 5s square plus 30 equals to 0. So this is the intersection point or intersection with the imaginary axis. So S is what? Sigma plus J's omega, and here because it is intersection with the imaginary axis, so S is equals to sigma plus J omega. Here sigma will be 0 because it's imaginary axis. So S is equals to here J omega. So omega will be equals to plus minus 2.5 J. So we have done all the steps for this root locus. Now let's plot this root locus diagram. We obtained the breakaway point, we have obtained the intersection, we have obtained the asymptotes, all the steps we have followed. Now just sketch this root locus. This is J omega and this is sigma, imaginary axis, and this is real axis. Okay. S equals to 0, we are having a pole. Then -1, -2, -3, -4, and this is infinity. So we were having S equals to -2 and we are having S equals to -3 as a pole. Okay. S equals to -2, S equals to -3. This is for k equals to 0, and for k equals to infinity, we are having S equals to minus infinity. Direction of the root locus we have obtained in our first step. Here we have obtained that the direction of the root locus we have obtained already in our step number 3, that for S equals to -3, it will be towards infinity. So we will plot here again this. Okay, so it will be like this. For S equals to -2 and S equals to 0, it will be towards each other. So it will be like towards each other. And here we are having the breakaway point where the two root locus for due to these two poles they are breaking. So this breakaway point is what? S equals to minus 0.78. This is our breakaway point. So from this point, that is minus 0.78, these two root locus they will be diverging, and they are terminating at k equals to infinity. Now these two branches will intersect the imaginary axis on the points which we have calculated as plus minus 2.5j. So this point is plus 2.5j and this is minus 2.5j. Okay. Now on these two root locus branches we are having the asymptotes. Okay, and these asymptotes will intersect the real axis at a point minus 1.67, which we have obtained in our step number. Here we have obtained that breakaway point we have already obtained here as this minus 0.784, and angle of asymptotes we have also already obtained, that is theta equals to 60 degree, theta equals to 180 degree, that is this is one of the asymptote, and theta equals to 300 degrees. So from here we are having the asymptotes. Okay, this asymptotes, this is making an angle 60 degree, this is making an angle 300 degree, and one is 180 degree, that is this asymptote. And this point, that is the intersection of the asymptote with the real axis, this point we have obtained in our step. So it was minus 1.67. So root locus we have plotted, we have completely sketched the root locus. This is one of the branch, this is one of the branch, and these are two branches. These two branches they are breaking away at this point. So totally we are having three branches. One part is this, one part is this, and third part is this. These two root locus they are terminating at k equals to infinity. This is terminating at k equals to infinity. Starting from a pole, terminating at k equals to infinity. And asymptotes, we have two asymptotes, and we are having this angle as 60 degree, this as 300 degree, and this is the third asymptote which is having the angle 180 degree. Okay, so this is the complete root locus diagram of this system. I hope you have understood this problem clearly. Thank you.